Many people are interested in how neural networks work. However, most of the materials online are geared towards IT professionals. That's why I decided to create a few videos where I will explain the basics of neural networks in simple terms. Obviously, any neural network consists of neurons. But what is a neuron? A neuron is a piece of computer code that performs certain calculations. Complex, you might ask. Let's delve into it. Do you remember in elementary school when you calculated formulas like a plus b plus c equals d during math lessons? Congratulations, you are doing the same thing that a neuron does. A neuron can have many inputs, but for example, let's take a neuron with 3 inputs. It also sums up the data. A, B, and C will be fed into the neuron's core. They will simply be summed up. Since there are 3 numbers to sum up, the neuron has 3 inputs. 1 input per number. Just like the school formula. The neuron will sum up our inputs and output D. Why is this useful? I'll explain with an example. Imagine you have a device that gives you data about the rain, the wind, and the temperature outside. Based on this data, you need to determine whether to wear a coat or if shorts and a t-shirt will suffice. We'll use a neuron for this. Rain, wind, and temperature are our A, B, and C. We'll feed them into the neuron. But how do you represent rain as a number? It's simple. In heavy rain, we will get a value of -1, and in dry weather, 0. Intermediate numbers for intermediate rainfall levels. Light drizzle, that's -0.1. It's like 1/10 of heavy rain. The same goes for wind. In a hurricane, it's -1. In total calm, it's 0. We'll handle temperature a bit differently. We'll take a comfortable temperature as our baseline. In extreme cold, it's -1, and in extreme heat, it's +1. Now, we'll feed this data into the neuron where they will be summed up, and we will get some result. On our inputs, everything that makes us dress warmer is marked as negative numbers, and what makes us dress lighter is marked as positive. So, we can assume that if the sum of the inputs is less than 0, we should dress warmly, and if it's more, a t-shirt will do. Let's test our assumption. If there's a light rain outside, -0.3, and a light wind, -0.2, and the temperature is slightly above comfortable, say, 0.1, our sum is -0.4. This number suggests we should wear a coat, as we might get wet. The breeze will chill us, and we might get cold. Now, what if we go to a warm country where the temperature is at its maximum, 1, and see if we need to dress in the same rain and wind? No, because our result is +0.5. Even if we get drenched in that warm rain and get hit by a hot wind, we definitely won't feel cold. Now you know how a neuron works. I suggest you rush to the store and buy a neural network just like the one I described here for $10,000. And it will help you choose your outfit. Just imagine, you followed the recommendations of the smart machine and went outside. And then... something went wrong.
Idiot! You didn't tell them everything.
Ouch! Of course. Sell the neural network you bought immediately. What? The store doesn't accept returns? All right. Leave a comment, and I'll compensate you for everything. I'll compensate you for everything. I still have something to tell you about the neuron. But wouldn't the neuron be impressive if it could only add inputs? Of course not. A neuron has something that makes it a magical tool. It's called weight. The term weight was not used to describe a physical quantity, but rather as the weight of a word or parameter. In our case, the weight is the importance of the input. The weight is a coefficient by which the input number needs to be multiplied before summing it in the neuron. Each input has its own weight. We'll add weights to our inputs and call them W1, W2, W3. Now we can adjust the neuron to any person. For example, you don't mind light rain, but you're very afraid of drafts. And at the same time, you easily tolerate various temperatures. Let's adjust the weights. For rain, we'll set a coefficient of 0.5. This will halve the impact of rain on the result. For wind, we'll set a weight of 2. This will double the wind's impact. And for temperature, we'll set it to 0, so it doesn't affect the result at all. Because what is temperature to a real walrus? Now, we send the data to the neuron again, the data we sent in the first example. We get minus 0.55. Definitely dress up. What about warm countries? Also minus 0.55. Because palms are palms, walruses are walruses, but we don't need a draft, especially with rain. Close the bus windows and turn off the air conditioners in the heat. Have you met such people? I think they've already bought similar neural networks. That's briefly about the perceptron. It's worth noting that in reality, neurons are not used alone, as in our example. Neurons are built into networks in various configurations, often in layers, like a cake. And the layers can consist of hundreds or thousands of neurons, allowing for the description of hundreds or thousands of parameters. The outputs of some neurons are fed to the inputs of others, and all of this is intricately intertwined inside. And such a multi-layered construction can have many outputs. Such a network is tuned or trained by adjusting the weights of all the neurons that make it up. But more on that in the next videos. Hit the like button, subscribe to the channel, and neural networks will always give you the right results.